All right, let's talk physical layer. First off, we just gotta stop for just a minute and talk about how amazingly awesome the physical layer is. Well, all the layers, but all of networking, really, it blows my mind. But when we talk about the physical layer, when we talk about someone sitting in a room somewhere, came up with the idea that by turning electricity on and off, or up and down, high voltage, low voltage, you can transmit information in ones and zeros through a wire to another device that can then have those same ones and zeros and do its own thing with them. Blows my mind. All of computing, all that stuff blows my mind. And the physical layer completely knocks it out of the park in terms of just absolute awesomeness. When we're talking at the physical layer, we are talking about, again, kind of like the data link layer, but even more specific. We're talking about connections between devices, every connection between device. So your connection to the access point's connection to the switch's connection to the router to the firewall, et cetera, all the way out to Google or Amazon or wherever you're going. Each of those connections is happening at the physical layer. The data link layer doesn't even happen at all of those spots, right? But the physical layer handles all of that stuff. So, physical layer devices. Physical layer devices are hubs and repeaters. A hub, we've already talked about in the switching video. Repeaters, a repeater is a hub with two ports. Takes information in one port, repeats it out the other port. That's all a repeater is. Cables, they're not really physical layer device. They're not really devices, but we'll call them that anyway. They fit on the physical layer. They operate on the physical layer. They are the way that the physical layer works. And then network interface cards are also physical layer devices. These are the way that your computer is connected to the network and the way that your computer transmits information on the network. So first thing, let's talk about cabling. You've almost definitely seen twisted pair cables. These are what's most commonly used for Ethernet. You can do Ethernet over other things, but what you're most commonly going to plug into, if you're plugging into the wall, is a twisted pair cable. And these are 4 pairs of wires that are twisted around each other to reduce interference so that they don't interfere with each other as much. Oh, first let's talk about some wires. There's a couple different orderings of wires, basically, that you can use. In the end, it really doesn't matter which one you use, as long as you use the same termination or ending organization of wires at each end. And if you look really closely at an Ethernet cable, you can see each of those wires coming out of the cable and being plugged into the connectors inside of the jack. So with Ethernet, you've got 10 base T, 100 base T, aka 10 megabit and 100 megabit Ethernet. Each of those uses only 4 wires. So in our cable, we have 4 pairs of wires, but 10 base T and 100 base T use only 4 of those wires. So 2 pairs of wires did nothing. One pair of wire was used to send data. 1 pair of wires was used to receive data. The rest of the wires just sat there and took up space. So the host, you would transmit on 1 and 2, receive on 3 and 6. Now that we're in 1,000 base T or gigabit Ethernet, gigabit connections, you're going to use all 4 pairs most likely, and you can send and receive wherever you need to. Here's where I was going. The unshielded twisted pair is the most common. You see 4 little wires that have just a little bit of insulation around them so they don't touch each other and interfere definitely directly that way, surrounded by just a little plastic casing. And all that plastic casing does is hold those little wires together and keep them from getting stabbed or pulled apart. It does not provide any protection from electromagnetic interference. Through those wires are electrical signals, voltages going up and down. Those are subjected to electromagnetic interference. If you ran those through the wrong area, you would get electromagnetic interference and you would have a very unreliable connection. You would lose data. The data link layer would look at the packets or the frames that it receives and say, that's garbage, throw it away, and you'd lose all sorts of stuff. So unshielded is fine. At the bottom, those are by far the cheapest though. So if you're not expecting to get that electromagnetic interference, then you're probably going to use Unshielded Twisted Pair because they're by far the cheapest. And these prices might be outdated. I think I pulled them up a year ago. Shielded Twisted Pair at the bottom of the list here. In addition to the little bits of insulation and the sheath or the casing that holds the wires together, you have metal that shields those wires from electromagnetic interference. Now, what you probably have is a metal mesh kind of around the entire set of wires that the things are going through, and then a little metal wrap around each pair of wires to prevent them from interfering as much with each other as well. And the last one we'll talk about here, a plenum cable, is the most expensive, and you could get unshielded, and I think you can get shielded plenum cables. But these are fire retardant. So inside of your building, if you have to run cables through, say, heating ducts or any kind of ducts, you probably want to use plenum cables because then they won't melt. And that's a good thing and probably required by most fire codes. So if you're running your wires not through their own conduits in the walls, but through existing conduits like your heating ducts or other ducts, then you probably want to use those plenum cables. Again, the most expensive type of cables. So inside of your cables, under that insulation, you have a couple different options for cores. Now, your core of that could be a solid core. And most commonly what you're going to see is a solid core. And that is one fat wire. And that's great. That's fantastic. It's wonderful. No complaints there. You could also have what's called stranded cables, where inside of each of those, instead of one solid cable, you have a bunch of really little ones. If you want to. You can buy solid core, you could buy stranded core cables. So in addition to your unshielded twisted pair or twisted pair cables, you have probably also seen a coaxial cable. If you've ever plugged in your cable internet or your cable TV, that is a coaxial cable. And that uses different kind of stuff. But rather than having everything in different wires, you've got one big fatty wire that carries everything. And everything comes through that wire. And so you have to use different things, different methods to keep sending and receiving and all that stuff separate. Whereas with our twisted pairs, we can send on one pair of wires, receive on another pair of wires. We don't have that option with coaxial cable because everything's on one, so we use frequency to separate those signals instead. So the coaxial cable is used to carry TV and internet to your house, and those signals, like I said, are split up by frequency. So different frequencies, just like your radio, when you tune your radio, all the same air, right, is carrying all of those different signals at different frequencies. And when you tune your radio to each frequency, you're picking up those different signals. The same exact thing's happening through that wire from your cable TV provider or your cable internet provider to your house. And those signals are split up and you have sending and receiving frequencies, different frequencies for each of those if you're using internet. So we'll talk a little bit more in another video about the modem, but the modem is a physical device. It's a physical layer device that does what's called modulating and demodulating. And it transforms a digital signal inside your network, because the ones and zeros are electrical voltages stuff inside your network, into that analog signal that's split up by frequency outside your network. Demodulating is translating that analog signal from outside your network to a digital signal inside your network. Another option we have is fiber optic cable, and fiber optic is awesome. Again, completely mind-blowing, because now, instead of electricity, we are sending information using light. And we are blinking LEDs on and off incredibly quickly to send information across a glass wire, we'll call it a glass wire, through a glass wire that in light. And it's just, again, I can't even speak because it's so cool that someone can do that and that we can do that, and we use it all the time because the backbones of the internet are primarily using fiber optic cable. So the fiber optic works because of principles of light, and as you see in this little animated image here, as light hits the edge of this glass tube, it reflects back inside. So instead of being lost and going out and immediately bouncing off into nowhere, it reflects back inside, and then we keep a lot of that signal, a lot of that light inside of the glass wire of fiber inside of the fiber. And you make that even better and lose less signal by surrounding that fiber with something reflective. And that keeps even more of the light from getting refracted out and getting lost. Powerline is another physical layer way to transmit information, and it does something so cool. And if you don't know, that's Powerline from the Goofy movie, and you need to watch it. Powerline takes the Ethernet, takes the power cables that carry, electricity to the outlets in your house, and it transmits information over those. So you can plug an Ethernet cable into one of these adapters in your basement, put another adapter on your main floor with another Ethernet cable, and those devices can communicate with each other as if they were plugged right into each other, more or less. Now, the adapters have to be plugged into the same circuit because that's how it works, but as long as they're on the same circuit, the same breaker, basically, inside of your house, then you can communicate. You can set this up and get a wired network inside your house when you don't have a physical cable, if you don't have Ethernet cables inside of your house. So cool. Another even amazinger part, radio waves can be used to transmit information. You knew this because you've probably listened to the radio. Radio waves can be used to transmit audio. Wi-Fi can transmit radio waves with digital signals, ones and zeros. And we won't go into the specifics now. We'll have another video or series of videos probably about Wi-Fi and how that all works. But using radio waves, just like your radio in your car, you can send and receive information. And that's how Wi-Fi works. You can also have microwaves, which are a different spot along the electromagnetic spectrum. And if you've ever seen a tower that looks something like this is using microwaves. And microwaves work by line of sight. So I can sit in one room in my house and connect to Wi-Fi in another room in my house. I don't have to be able to see the Wi-Fi access point for that to work. Microwaves, however, do need that line of sight to function. So you see these big towers, and somewhere within the line of sight, around the curvature of the Earth, before the curvature of the Earth takes it out of sight, you've got another tower just like it to receive and possibly rebroadcast the information to the next spot along the way. And you can send information using microwaves. It's really cool, used all the time. The last type of physical communication, physical medium communication we're going to talk about, also with radio waves, is in space. A lot of long distance communication. Now, if you're sending information to Europe, you're probably not going through a satellite because there's faster ways. There's undersea cables that get from you to Europe, so you don't need to do that. But if you are transmitting information, say, from a remote location from a military location in Afghanistan, for example. If you're out there in the middle of nowhere, you don't have the physical infrastructure, perhaps, to directly communicate, to use a wired land-based communication. So you could use a satellite, or very often news reports use this. And they bounce those communications off of a satellite to get a signal anywhere, because satellites are up in the sky. You can see them basically from wherever you're at. As long as you can see the sky, you can your radio can see the satellite and transmit information there. The only problem with satellite communication is latency, because it's an awful long way to space and back, and information can only travel at the speed of light, and these radio waves travel at the speed of light. So if it's bouncing up to a satellite and back, you've got what's called latency, or a delay. And that's where that delay comes from when you're watching a news broadcast and they've got someone on location in Afghanistan or someone on location somewhere where they can't directly connect to a physical infrastructure. They're going to use that satellite and communicate that way, but it introduces that delay of sending information up to space and back. So the physical layer, again, is electrical signals, it's waves, it's light flashes in fiber optics, and really, it's a whole bunch of different ways that we can send ones and zeros from point A to point B. And that's what the physical layer does.